Welcome to Algebra 1, Lesson 8. So today we're going to talk about roots and root simplification. Remember, a root is another way of saying radical. Radical is this sign right here that we're very used to knowing and calling a square root. So we're all very familiar with square roots that make sense to us, that are rational. For example, like the square root of 4. The square root of 4, if you were to plug it into your calculator, you'd get an easy answer, a number without a decimal, just simply the number 2. That makes this a rational number. Remember, rational it's another word that just means it makes sense. It's something that we can understand. It's understandable. It's rational. Okay. But if you were to plug the square root of 12 into a calculator, you get 3.4641011615, and so on. It keeps going on and on. So the square root of 12 doesn't seem to be a rational number. But it's not in its simplest form. So we want to know, what truly can we break this down to? What is it in this square root of 12 that's making it this irrational thing that we can't understand, this decimal that never ends and never repeats? So what we do is we're going to break it down a little bit, and I'm going to show you how we do this, but it ends up being 2 square root 3. So it has a rational number of 2 in it, as well as an irrational number of the square root of 3, okay? So you can go ahead and plug both the square root of 12 in your calculator and 2 square root of 3 in your calculator, and you'll see that you get the same decimal. All right, so how do we do this? How do we simplify square roots? Well, that comes down to the product rule. Okay, the product rule for radicals means that if you have something that's under a radical that's the same as a times b, it can be rewritten as the square root of a times the square root of b. So let's look at that in our example we had of the square root of 12. So the square root of 12 here, we know that 12 is the same thing as 4 times 3. So we can rewrite this as 4 times 3. And look, that's in the same format here as the square root of a times b, 4 times 3. So that means using this product rule, I can break this out into 2 separate roots. So the square root of 4 times the square root of 3. Now, one of these we can complete, and the other one is an irrational number. So the square root of 4, we are able to complete. We know the square root of 4 is 2. And then radical 3 is our irrational number, so it has to stay just like that. So that's how we get from the square root of 12 to 2 square root of 3. This is square root of 12 in its simplified version. So if you're ever asked to simplify a radical, this is the type of process that you will go through. Now, in order to do this process, it's always good to know a good number of your perfect squares, is what we like to call them, when you can take a number and find the square root and it's just that perfect number. So here I've got some of the a chart, which these are numbers you should have memorized. If you don't, it's okay. We can use calculators in all of our schoolwork. We get to use notes, but you do need to write these out for yourself to reference later on. In a test, if you're in public school, you get a note card when you're taking the test. So you could write this out on a note card if it makes sense for you to build your note card as you're going through the unit, so you don't have to do it last minute. The things that you see are important. All right, so 2 times 2 is 4. So we see that the square root of 4 is going to be 2. So it's easy for us to look at these numbers right here. These are the key numbers we would be looking for when we're simplifying radicals. If we can find a 4 or a 9 or 25, 16, 100 even inside one of these radicals that we're supposed to simplify, it makes the process so much easier. Matter of fact, I'm going to show you one more that you might want to know. 15 times 15 is 225. 25. Okay, so that's one that you should know as well. All right, but if you don't happen to have all of those memorized or write down the chart, or maybe if you found one, but you're not sure if it's the smallest it can get, because remember, just like with fractions, when you simplify, it's supposed to get as small as it possibly can. Sometimes you have to simplify the fraction multiple times before you get the final answer. So it's the same with radicals. So the easiest way to make sure that you get the absolute correct answer is to make sure you are finding its prime factorization. And let me show you how we do that. If you remember what a factor is, it's a number that when multiplied by another one gives you a product. So you're going to get a multiplication answer. So when you factor a number, you're finding the things that are used to multiply to make that number. So essentially, we're going to divide out some numbers to figure out how many things we can divide out of this. 216, I know, is divisible by 2 because it's an even number. So I'm going to start with 2 because I know that's prime. So I know that it stops right there. So 216, when it's divided by 2, is going to be 108. Okay. Now we can break 108 down some more. I've got a 2, half of 150, half of 8 is 4. 54. I like to cross things out when I'm done with them, then I'm not tempted to write them in my answer. So 54 is even as well. I can divide that by 2. Half of 50 is 25, plus half of 4 is 2, is 27. Now 27, I know, can be divided by 3 and 9. Okay, because 9 times 3 is 27, and 9 I know is 3 times 3. Now, the prime factorization of this is 2 times 2 times 2. So 3 2s. 1, 2, 3. 2 times 2 times 2. And 3 times 3 times 3. So 3 3s. 1, 2, 3. Well, Miss Andrea, how on earth does that help us? Well, if you remember what a radical is, it's we want to figure out what we can break out of this radical. So square root of 4's answer is 2. So what two things got multiplied by this 4 to come out? Well, 2 2's did. So 2 times 2 made that 4 equals 2. So if you notice, anything under this radical is double. And when it moves out of the radical, it's a single. Okay. Now, I have a lot of students who call these houses for whatever reason. They say this 216 is inside the house. Okay. And so that made me think of one of the ways that I remember or helped people to remember what you do when you move people out of the house. Usually people will move out of the house when they get married. And when people get married, two become one. They join together in perpetual unity, right? So we're going to have these numbers get married. If you see a pair of numbers, they're going to get married together and move out of the house, and two will become one. Okay, so I've got a pair of 2's and a pair of 3's, and they're going to move out of the house. So I'm going to put them out here on the outside of the house. I'm going to draw my radical, which is what we're calling the house. And then I'm going to put my lonely onlys back inside the house. I've got a lonely only number 2, and I've got a lonely only number 3 here. Okay, so my pairs that got married, my 2 and my 3, they're outside of the house here. And so now I just complete this multiplication. 2 times 3 is 6, and 2 times 3 is 6. So the square root of 216 simplified is 6 square root of 6. All right, so let's look at this one here. 294. Again, it's even, so it should be pretty easy for me to divide by 2. 294 divided by 2 is 147. Now you may think, oh my gosh, I don't have a clue what 147 can be divided by. But this is where some of those division tricks you learned way back in elementary school can become helpful. One of the division tricks that you learned is that when you add up all these numbers, if they equal to a number that's divisible by 3, then guess what? Your number is also divisible by 3. So let's give that a shot. 7 plus 4, 7, 8, 9, 10, 11, plus 1 is 12. 12 is divisible by 3. So I know that this is going to be divisible by 3. I'm going to plug that into my calculator. 147 divided by 3. I find out that it is by 49. So 3 times 49 makes 147. And I know 49 is actually a perfect square. 7 times 7. So I have got one pair that's going to move outside of the house here. So I'm going to put a 7 outside of my radical. Inside of my radical, oops, I used that 49. Let me make sure to cross it off. Inside of my radical, I've got a 2 and a 3 left over. 2 and a 3. So my answer is 7 square root 6. So 2 square root of 249 is 7 square root 6. All right, let's look at this last one over here. Oh my gracious, it looks so different. There's a number already in front. Well, all we have to do is ignore that for right now. So it's actually not going to be anything we even need to look at. We're going to just break out what's in the radical the same way we did all these others. We're just going to find its prime factorization. Well, since this ends in 0, I know it's divisible by 10. Look at that. 10 times 54. That's pretty easy to break out. And then 10 is not prime. So I'm going to do 2 times 5. 54, I know, can be divided by 2. And 2 times 54, okay, 25, 26, 27. I think we actually did that over here. We did. 2 times 27. 27, I know, can be divided 3 and 9. And 9 can become 3 and 3. All right, so let's see if we've got any pairs here. These aren't quite in order, so I do want to write my prime factorization here at the bottom. I see I've got 2 number 2s, so 2 times 2, and I've got 1, 2, 3 number 3s, 1, 2, 3, and I've got 1 number 5 here as well. So let's match up our lucky pairs. We've got a pair of 2s and a pair of 3s. They're going to get married. 2 will become 1 and move out of the house. So I've got a 2 times a 3 outside of the radical. Now I've got my 3 and my 5 still inside the radical. Now this is where we need to look back and say, oh my gracious, I have to remember to bring down that 7 that I had left hanging up there before that I did nothing with. So the 540 broke down to our prime factorization of all of this, and our 7 we just bring down after we start to move some stuff outside of the radical. Now we just do our multiplication. 7 times 2 times 3 is going to be 42, and then it's radical 15. All right. Looks like I got everything correct there. So let's go ahead and move on. Make sure you're taking notes. This would be another good thing to take a note on. We previously talked about the product rule. If you recall, that was when you have a radical of A times B, you can rewrite that as a radical A times a radical B. Well, product means multiplication. Remember, product is the answer to a multiplication problem. So this one is actually called the quotient rule. And what it is, as you can see, there's a fraction here, and fraction is a type of division. Quotient is the answer to a division problem. So this is a quotient rule. It's basically the exact same thing as this product rule, only using division. It's saying you can have it all under one radical sign, or you can break it up into 2 radical signs. Either way, if you see it this way, you're allowed to break it up to that way. If you see it that way, you're allowed to break it up to, or combine it to make it this way. Whichever way makes it easier for you to do the work. Let's see some of this in action. So here we've got 3 different fractions with radicals. This first one here, we have a large radical over the fraction 5/9. Well, what's going to be easiest for us here is if we break these up. Radical 5 over 9. Okay? Oops, over radical 9. Now, are we able to simplify radical 5 at all? No, it's in its simplest form. So radical 5 over What's the radical or the square root of 9? Well, that's going to be 3. And so square root of 5 over 3 is our final answer there. Here, we can do the same thing. Radical 25 over radical 81. Okay, well, what's the square root of 25? It's going to be 5. Square root of 81 is 9. All right. 5/9. That's in its simplest form already. We're moving right along. Okay, this one's already separated. But I know we can't find a square root of 5, so there's got to be something different we can do here. Well, let's try putting it together. 160 over 5. Since remember, fractions are a division problem, let's plug that into our calculator and see if we can get an answer. It's 160 divided by 5 is actually 32. So I'm going to write this right here. Can't forget my radical. Radical 160 divided by 5, which is 32. So it's radical 32. Well, I don't remember 32 being any of those perfect squares. So I'm going to go ahead and start my factor tree to find the prime factorization of this number. 2 times 16. Wait, there's a perfect square right there. I can stop right there and I'm going to put square root 16 times square root 2. I know the square root of 16 is 4 times square root of 2. And that is my final answer. If you did not know this was a perfect square, you could continue on and break this out into 4 times 4, and then 2 times 2 and 2 times 2. And you'd still end up with the same exact answer. It would just take you a little bit longer to get there. Oops, guess I didn't input the answers on that one. All right, so let's look at the simplifying square roots. This is your opportunity to give it a shot on your own. I want you to go ahead and press the pause button and try these 5 problems on your own, and then unpause it when you're ready to go over the answers. All right, welcome back. So we've got 2 radical or square root 98. Okay, I can't really think of any, there's nothing that comes to mind that can divide into this that's a perfect square. So I'm just going to start by doing a factor tree and see if I can get something. I know 98 is, since it's even, is going to be divisible by 2. 2 times 49 is 98. I remember 49. 49 is one of those perfect squares. It breaks out to 7 and 7. So I can do square root of 49 times square root of 2. And I can't forget my 2 here at the beginning. So I've got all 3 things. I've got my 2 at the beginning, right here to here. And then square root of 49 times square root of 2, which makes my square root of 98. Now, next step, 2 times square root of 49 is 7 times square root of 2. 2 times 7 is 14 square root of 2. And that's my final answer. All right, I'm going to switch colors here so it's easier to see each problem. 27. I already see a perfect square in this one because I know that 3 times 9 is 27. So this is the same thing as 9 times square root of 3. If you notice, how I have my memorization fact, my multiplication facts memorized is with the smaller number first, 3 times 9. But when I write it down, if you notice, like with this one, I said 2 times 49, but I wrote it down 49 times 2. You want to have the perfect square first because it's proper form to have the number that's not in the radical as a coefficient to the radical, because we're actually going to see in a little bit in the next lesson how these radicals are kind of treated very similar to variables. And so you always want to have the number part first and then the radical part last, or the irrational number second. All right, so square root of 9 times square root of 3 ends up being 3 square root of 3. Okay, so now this one, I know I can break it up into square root of 16 over square root of 25 because I know those are perfect squares. Square root of 16 is 4 over square root of 25 is 5. So my answer is 4 over 5. I forgot to change numbers that time. Sorry. Here we go with the new color. Excuse me. Square root of 48 over 9. Okay, well, I know 9 is a perfect square. I'm not so sure about 48. 12 times 4. I bet there's some 4s in there. I bet 16 is a factor of 48. So I'm going to break it out into 48, square root of 48 over square root of 9. And then I'm going to jump over here to the side and just take up some of this unused space and see what I can find in 48. Instead of using 2, let me go ahead and I'm sure there's a 4 in there. So 4. 48 divided by 4. 4 goes into 4 one time. It goes into 8 2 times. It's 12. And that's 4 and 3. So right there, I found a pair and then a lonely only. So my square root 48 is going to equal 4 because they're going to get married and move out of the house. Lonely only stays in the house here. 4 square root of 3. All right, so I'm going to have on the top 4 square root 3, and on the bottom square root of 9 is 3. And that is my final answer for that one. All right, last one. Here we go. This one, I can easily see a perfect square. Hopefully you saw it too. It's the number 100. So 500 can be divided up into 100 times 5, right? And 100 we know is a perfect square. So I'm going to do square root of 100 times square root of 5. Okay, square root of 100 is 10 square root of 5. All right, let's see if I have the answers written down, if I got everything correct. Oh, I wrote them down, but they're kind of over my work here. 14 square root of 2, 14 square root of 2, 3 square root of 3, 3 square root of 3, 4 fifths, 4 fifths, 4 square root of 3 over 3. That's the same thing. It's really hard to read. I'm sorry, guys. And then 10 square root of 5, 10 square root of 5. All right, I hope you were able to get all of those notes written down, all those examples written into your notes there. Now, we can continue this simplifying of square roots over into some variables. So here I've got an example for us. We've got 3 square root 500 x to the third. So this is in parentheses because our square root here is written by the computer, and the computer does not extend that square root to show you exactly everything that's in it. So this is square root of 500 times x to the third. Okay, so what we're going to do is just go ahead and break this out into, I want to break it out into 3 different groups. My first group is going to be the number that's already outside of the radical. I've got a 3. And remember, when things are touching, they're multiplying. So I'm going to put a multiplication symbol there. And then I'm going to break out my 500 right here. That's this part, right? And then I'm going to break out my x cubed. That just makes it a little easier for me because it's easier for me to do the factor tree or factor out some things from 500 than it is 500x cubed. So this allows me to separate it into more manageable pieces. And so what I'm going to do, we just did the square root of 500. I happen to know that that breaks out into 105. So I'm going to go ahead, and my 3 is just going to come on back down, stay exactly where it is. And then I'm going to do the square root of 100 times the square root of 5. Okay. Now, x to the third. X to the third is x times x times x. That is its prime factorization. It's as simple as that. Now, in order to figure out what needs to come outside of the radical, you think about, oh, well, what pairs can I make? What can I have get married here where 2 will become 1? I have 1 pair of x's that's going to get married and move out of the house, and then 2 will become 1. And then I have 1 lonely only right here that's going to stay inside the radical house. Okay, so here I've got 3 times radical 100, or square root of 100, times square root of 5 times x times square root of x. Well, there's one more thing I could simplify here. 3 times square root of 100. That's the thing I can simplify and make it a 10 times square root of 5 times x times square root of x. Well, I like that, but I don't like the order of it. I want all my radicals to be put together. And remember, with multiplication, order is not important. Order doesn't matter. So I can switch this around however I see fit, whatever makes it easier for me. So I'm going to put 3 times 10, and then I'm going to put this x here, times x. Okay, and then times, I'm going to go ahead and stick these back under the same roof here, 5 times x. Because remember, our product rule said AB, radical AB equals radical A times radical B. And this was radical A, this was radical B. I have them separate on this row and then together on this row. Okay, so I'm following the rules when I do this. Now I'm just going to multiply it out. 3 times 10 times x, that's 30x square root 5x. Okay, so you can see how this works exactly the same with radicals as it does with numbers. You find the prime factorization, find any pairs you want. You're going to move them outside of the radical and leave any remaining variables. All right. So how many answers does a square root really have? You know, if you're a forward thinker, you like to think ahead, jump ahead of the teacher. I know that I've always had students that like to jump ahead and ask me questions. I'm like, wait, I'm about to get there, I promise. So how many answers does a square root really have? Well, you know that a 4 is one that we like to use a lot. We say, okay, well, 2 squared equals 4. Okay, well, what is negative 2 squared equal? Well, that also equals 4 because negative 2 times negative 2, I've got an even amount of negatives. That means my answer is going to be positive, and 2 times 2 is 4. So really, the square root of 4 could either be a positive 2 or a negative 2. It can be a positive or a negative 2. Look at that. Now, what the rule that mathematicians have generally settled upon, you know, humans, we like to argue, so there's still some quarreling going on, but the generally accepted rule is that if the radical is written into the problem, you take whatever sign is in front of it. And most of the time, there's not going to be a sign. So that means it's positive. So your answer for square root of 9 is going to be x equals positive 3. Now, if it said negative square root of 9, what would your answer be? It would be x equals negative 3. Okay. But if it said plus or minus the square root of 9, guess what they want? They want both answers. So plus or minus 3. Okay, so whatever the sign is before the radical is the sign that they want in the answer. That is what is implied here when the radical is already written for you. But what happens when you insert the radical into the problem yourself? Say you have a problem you're trying to solve, like an algebra problem that ends up being x squared equals 9. Well, in order to undo this squared, you take the square root. Just like in order to undo multiplication, you do division. In order to undo addition, you do subtraction, etc. Well, in order to undo a square, you do the square root. Remember, we have to do it to both sides. So we're the ones that introduced the radical in this situation. So because we input this, we don't actually know which one is the correct answer, whether it's 3 or negative 3. So our answer has to indicate both x equals positive and negative, positive or negative 3. Okay, now this is important because if you remember when we got into polynomials, we talked about linear polynomials. We also talked about quadratic, and we talked about the ones that look like this. Well, anytime you're going to be asked for a solution or what x is, it's going to be where does it cross the x axis. Remember, you have a coordinate plane, X and Y. So if you notice with a parabola, it's got two places most of the time where it crosses that x-axis. And many times one will be positive and one will be negative. So that's why it's extremely important that when you introduce the square root of a number into solving any equation, you want to make sure to consider both answers. Now, sometimes when you use it as a unit of measure, like how many miles did so-and-so run? And if the answer ends up being x squared equals something and you do it, you know you're not going to come up with a negative answer because nobody ran a negative amount of miles. That sure would be interesting. Or if you're using it for a unit of measure for anything in geometry, which we're going to see in just a minute, you're going to want a positive answer. Okay, so your general rule is whenever you see an equation containing a square root already, like this one right here, you can assume the positive unless it's written the plus negative or simply a negative sign in front of it. Now, if you're the one, point 2 here, if you're the one that introduces the radical, both positive and negative answers must be considered. That doesn't mean it's always there. It means it has to be considered. Okay. Now, if your answer is for a type of measurement, most of the time it's just going to be a positive answer. So we talked about how we have to use both positive and negative answers when we insert the radical into the equation. So when do we do that? We do that when we're solving equations to undo those squares. So the first thing we have to do in solving equations with square roots is to isolate the variable with its exponent. Then you take the square root of both sides of the equation and you simplify the radical. Now, English is hard when it's in words. When you have math in word form, it's like, oh, what does all that mean? So guess what? We've got an example for you, make it a little easier. Solving equations using radicals. Well, the first step we said was get the variable with the exponent by itself. So our variable and exponent here is x squared. All right. So in order to do this, remember we have PEMDAS. Okay, parentheses, exponents, multiplication and division in the order they appear, addition and subtraction in the order they appear. If you were completing this math problem, you would work downwards. But since we're undoing it to get the x to reveal itself, we're going to move upwards. So we're going to move in the opposite order because we want to undo all the things that were done to x so it can reveal its true value. So the first thing we undo is any addition or subtraction. Here we have addition. To undo it, we're going to do some subtraction. So we're left with 3x squared equals 24. Then what's happening to the x squared? It's being multiplied by 3. So that's our next step to undo. So let's divide both sides by 3. We're going to get x squared equals 7, right? 3 times 24, up 8. X squared equals 8. So now, how do we undo this square? That was step 2. Once you get the variable with the exponent by itself, you have to undo it by inserting the radical. So we have to do it, what we do to one side, we have to do to both sides. So if we undo this square by adding a radical on this side, we also need to add a radical to the other side of the equation. So this cancels out that, and we're left with simply x equals square root of 8. Well, I'm going to go ahead and break this out. I know 8 can be divided by 2, which is 4 divided by 2, divided by 2. 2 times 2 times 2 is 8. 2 times 2 is 4, times 2 is 8. I have got a pair right there. Woohoo! Dun, 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 dun. They got married, moved out of the house. And then I have a lonely, only number 2 right here. So x equals 2 square root of 2. But wait, what did I forget? Is that my final answer? Is that everything? No, we don't know if this square root of 8 is going to be a positive or a negative because I'm the one that inserted this radical sign. So you need to make sure you input the plus and the minus right here before the 2 square root of 2. What I like to do is if I have something like x squared equals 8, and I know I'm going to do a radical on both sides, immediately after I write that radical, I go ahead and write plus and minus down here so that I know I'm not going to forget to add it. Because it's always good to go back and look at your work and make sure, hey, did I do this correctly? Am I forgetting anything? Does this make sense before you submit your answer? But it's also good to have little habits that you know work for you, that work every time, that help you to avoid the simple mistakes. It's usually the simple mistakes that trip us up in math. I find most students know what they're doing. It's just these simple mistakes that they get them all tripped up and turned around. There we go. X equals plus or minus 2 square root of 2. And that means both the positive 2 square root of 2 and the negative 2 square root of 2 are our answers. All right, solving equations using radicals practice. There we go. Now you can read it. So I want you to go ahead and pause this, complete these 3 problems on your own, and then we'll be back to go over the answers. All right, so our first step here we're going to do is get x squared by itself, our variable with its exponent by itself. We're going to do that by adding 25 to both sides. So I'm going to have x squared equals 25. This is easy enough. In order to undo this, I'm going to put a radical on both sides, which means I need to have a plus and minus answer. Okay, this gets undone, leaving only x. Radical 25 or square root 25 is 5. So x is plus or minus 5. Next question. X squared equals 56. In order to get this, the variable and the exponent by itself, I have to divide by 2. So I'm going to have x squared equals, divide by 2 is 25 plus 3, 25, 26, 27, 28. All right, so now I've got x squared. I need to put a radical around both those, which means my answer has to be plus or minus. Okay, these are going to cancel out. I've got an x on this side. Square root of 28. I'm not so sure that's a perfect square, so let's go ahead and divide this out. 28 can be 2 times half of 2 is 1, half of 8 is 4. Ooh, 14 is 2 and 7. I found a pair. 2 are some pairs and a 7 lonely only. So my 2's got married. 2 became 1 and moved out of the house 2. And my lonely only 7 is going to remain there in the house. So x equals plus or minus 2 square root of 7. All right, last problem. You ready? You ready? It's the last one. Woohoo! All right, we have got 40 minus x squared equals negative 5. Well, this is something I see people having simple mistakes over all the time. You have an x here, and what's happening to it? What do we need to undo to get this variable and its exponent by itself? Well, we have to get rid of this 40 here. So I've seen people add 40 to both sides. Well, let's look at this for a second and figure out if we can see why that's wrong. Hopefully you didn't do that. Hopefully you got it right. The 40 is not being subtracted from this x, right? The 40 is actually being added to the negative x. We can actually rewrite this problem, negative x plus 40. The negative is with this x. What's in front of this 40? A positive, right? So when you're undoing this, we need to undo the 40. The 40 sign is positive. The negative is stuck to this x. It's not stuck to the 40, it's stuck to the x. You always look at the sign in front of the number that you're undoing, okay? It doesn't matter if there's a subtraction behind it. What matters is what's in front of it. And since this is a positive 40, we undo this by subtracting 40 from both sides. Okay, so that leaves us, we cannot forget when we write our x squared here to have the negative come down with it. It's stuck to it. It's its sign, right? So negative 5 minus 40 is going to equal negative 45. Okay, well, my variable is not by itself right now. It has a coefficient. Remember those magical math mishaps that happen where things just disappear? It's a -1, right? We have a -1 hidden right there. So how do we undo this? It's being multiplied. We divide. And if we divide by a negative, well, all that does is change the signs. So if we divide negative x squared by -1, guess what? We get a positive x squared. If we divide negative 45 by a -1, what do we get? A positive 45. All right. Now we need to take the square root of both sides. That means I have a positive or minus answer. Okay, that cancels out, leaving me with an x. Square root of 45. I see a 9 in there. And I know 9 is a perfect square. So I've got a 9 times 5 makes 45. So that's square root 9 times square root 5. So it's 3 square root 5. All right, so x equals plus or minus 3 square root 5. And that's my final answer. Let's see if where I put these numbers here for us. All right, ooh, I'm so close. Plus or minus 5, got that correct. This one's kind of on top of each other, but you can see it's plus or minus 2 squared root of 7, which is what I have written in the green. Here we have plus or minus 3 radical 5, plus or minus 3 radical 5. All right, so the very last thing I wanted to show you that I did want to get into is how do we apply this? Okay, we talked about sometimes the negatives. Most times the negative won't be applied to units of measure, okay, until you get into physics and stuff. So simplify the square roots of application. We have a diagonal of a square that's 20 inches. What are the side lengths? Okay, well, gracious. What's the first thing we're going to do? A diagonal of a square. This is all English. This is gibberish when it comes to math. What do I know works well with math? Well, pictures work well with math. So if you have something you can draw as a picture, that's always helpful when you have a word problem. So I know that I'm going to have a square. So I'm going to draw a square. Draw a square right here. Okay, not the best square, but it's a square. And I know it has a diagonal. Well, what is a diagonal? A diagonal goes from one corner to the other corner. You could choose any two corners, one corner to the opposite corner. It cuts the square exactly in half, creating two congruent triangles. And we know that that diagonal is 20 inches. Okay, it says, what are the side lengths? Okay, well, what do I know about a square? What do I know about a square? I remember a square, every single side is exactly the same length. Look at that. So x and x and x and x. I'm going to put x on all of them because it's all going to be the same number, right? I know I want to find the side length. So really, I'm only looking for one x. But okay, what else do I know about squares? Well, I know squares all have right-angled corners. You know what? I've got a better looking square for you here. There you go. I know that squares all have right angles in them, right? We remember that. We know all the sides are congruent. Now, I knew that this diagonal cut it into two equal, exactly the same, congruent triangles. Let me just draw one in here. I've got this yellow triangle right here. Hopefully y'all can see it. It's a triangle, right? Now, in this triangle, I see that it is a right triangle. And what do I know about right triangles? Well, I know a secret formula that allows me to know all of the side lengths of any right triangle. That secret formula is called the Pythagorean theorem. And it is, in case you don't recall, a squared plus b squared equals c squared. Now, the only letter that matters where it goes is C. C has to be the special line in the triangle called the hypotenuse. And what is the hypotenuse? The hypotenuse is the side that is opposite the right angle. So the right angle kind of points at the hypotenuse. So 20 is C. That's the only one that matters. A and B aren't going to matter. I can call this one A and this one B, or I could call this one A and that one B. It doesn't matter. But what matters even less is they're both X. So guess what I can do? To fill in this formula, I'm going to put X squared plus X squared equals, what is C? I know C is 20. 20 squared, right? So in order to complete this, the first step I have to do is I'm going to simplify. I'm going to combine like terms on this side. So x squared plus x squared. What do I remember about adding variables with exponents? Well, I remember my product rule or my combining like terms means when I have to have the exact same variable, both the letter and the power. These are exactly the same. And when I meet that condition, then I add their coefficients. What is the coefficient of this term right here? It's a coefficient of 1. What is the coefficient of this one? It's a coefficient of 1 as well. So I'm going to go ahead and write my x squared here. What is 1 plus 1? Well, it's 2. Okay, so 2x squared. Now I want to simplify this a little bit. So 20 squared. 20 squared is going to be 400. Okay. Now, remember our steps for solving when we have something with a squared here on our variable. First thing we need to do is get this by itself. So 2x squared is being multiplied by 2. So I have to undo that too. X squared equals 200. Now, in order to undo the square, I do the radical of both sides. Oh, that means I got to do a plus or minus down here. Can't forget that. So I'm undoing this, and that leaves me with an x on this side. Square root of 200. Okay, well, that's the same thing as 100 times 2. Radical 100, radical 2 is the same thing as 10 radical 2. All right, so here's my answer, 10 radical 2. X is plus or minus 10 radical 2. Is that my final answer? Well, I know that I need to consider both my positive and my negative answer because I'm the one who inserted the radical. However, can my triangle have a negative 10 square root of 2 side? No, it can't. So the side of my square, which is also a rectangle is a square is a type of rectangle, 10 square root of 2 on each side of these, 10 square root of 2. Every single side, even the ones we weren't working on, are going to be 10 square root 2. Okay, so what are the side lengths? The side lengths are 10 square root 2, only the positive, because it's a unit of measure, because we're measuring the length of something. Okay, and you cannot forget our unit of measure right here, inches. That is your official answer, 10 square root of 2 inches. All right, hope that makes sense, and we're gonna get a little bit deeper into radicals in the next video. See you soon.